suddenly doesn't transfer to your sample. In electron beam generated in SCM, that's only scan the surface and generated some maybe characteristics X-rays and all these things. Maybe secondary electron we can call, and that is detected and image is formed. Here it is not like that. Here your electron beam has to pass through your sample, so it should have more energy. So here we are using 300 kilovolt field emission gun. In SCM we are using 20 kilovolt. So compared to that, now energy of this electron beam is more high here, because your beam has to pass through your sample. For that we are using maybe 300 kilowatt like ST tank and all. But now generally the soft sample which get damaged with this electron beam, we are not applicable here. So we are using very small quantity of your material sample basically. This is a high resolution transmission electron microscope. It is generally works on the solid materials, or powders, which should not be easily damaged with the energy of the electron beam. So biological sample, as you told us, so there are different microscopes. So biological microscope uses 100 kilovolt only, and they uses a different technique to reduce the energy of electron beam, so that your structure doesn't deform. So for different application, there are different electron microscope. This we are using for material chemistry, material sample, which is very sturdy, gold, silver, copper, aluminum. So that doesn't get deformed with this electron energy. Those are a solid material. No? For the biological sample itself, sample preparation is totally different. And again, the electron microscope use are totally different with the apertures, lower energy. 80 kilovolt only we use, 80. Here we are using 200. Here we are using 300. 200 is different. This is a 300 kilowatt fake. This again is a very demo piece we purchased in 20 years back. 300 kilowatt is a very big voltage, 3 kilovolt. I am not talking about voltage. See, electricity in our house is 230 volt only. But 300 kilovolt, that 300,000 volts. Yeah. So that generates a very intense electron beam, so that it can pass through your sample. And then you can magnify it, so your energy is spread, and you can get a good pictures with that. The only tedious thing is your sample should be transparent here compared to SCM. So you have to make so many things. There are other instruments available, techniques available to make your sample thin. For us it is very easy, because our samples are chemically synthesized powders. So powders, as I told you, you just disperse it in the solution. So your powders, all particles are spread everywhere in your solution, and one drop of that solution you put it. So we assume that all your particles are spread on the surface. It's very easy. But if a solid sample, then how you make it a very small, transparent, na? So for that, different techniques are available. And for biology, somebody was asking, you only asking.
Yeah.
So there is a cryo microscope is there, cryo-TM. So it's help the structures now, they are preserved in original state. See, your biological sample cannot be dry. If you dry, that lose your morphology.
Correct.
So for that, cryo-TM is there. That is different techniques used for the biological sample.
Okay.
So it is the sample preparation is the most critical part in this machine basically.